Hello and welcome to another mathematics tutorial with Mr. Thompson. Today we're looking at one of my personal favourites, quadratic expressions and factorising them. If you're looking at this, you could be year 10, 11 or 12. And all of the things you'll see here can be useful at any of those levels. So let's dive straight in. Here's a quick quadratic and we want to turn it into a set of double brackets. Now the way I do it is, I am looking for to put something on these two arms here that multiply to give me that guy over there, okay? So basically, in this situation, it's got to be x times x. And that's the only things that can really multiply to give me x squared. In these positions here, I'm looking for two numbers that will multiply to give me 6 and add to give me 5. So very simple, it's obviously 3 and 2, and both numbers are positive because there's only positive signs on display here. And then basically that becomes my brackets, x plus 3 times x plus 2. And the way you double check it is you look across the cross. By going that way I get 2x, and by going that way I get 3x, and together they give me that middle term of 5x. Looking at the next example, it's a little trickier. Basically the numbers still hold. I want x times x over here again. This time I'm looking for two numbers that multiply to give me negative 30 and add to give me minus 7. Well, I'm thinking 3s and 10s are good for 30s and 7. Minus 7 dominates, so if I go negative 10 and plus 3, and I just check my crosses, this one here gives me minus 10x. This direction here gives me plus 3x. So when I combine them, I get negative 7x, which is the middle term. So therefore I can go straight to my brackets there, x plus 3, x minus 10. And that's how I do that. Next one. Again, kind of slightly different again. This time, get x and x here again. But this time I get 21, but that's a positive number and the middle term is negative. So both of these numbers are going to have to be negative. I'm seeing 7 and 10, I'm seeing 21, so I'm thinking again 7s and 3s are looking good here. Minus 7 times minus 3 is plus 21. And if I go this way across the cross, I get minus 3x. If I go that way across the cross, I get minus 7x. Together I get that middle term of minus 10x. So I'm happy that those are my two brackets there. X minus 7 times x minus 3. Okay. This one is a special case, but we'll work the problem as before. Times to get 9, add to get 6. I'm thinking 3 and 3. That's fine, but what we'll notice about this one is actually a perfect square. X plus 3 times x plus 3. If you spot that the last number here is a perfect square, there's a good chance you're going to end up with this same repeated root. And when you write it, of course, you can write it as just x plus 3 all squared. Another scenario, this time it looks a bit different. There's no middle term here. That's because we're in a difference of squares situation. And the difference of squares, the rule is a squared minus b squared can be written as a minus b, a plus b times a minus b. So this one I've got x squared minus 9 squared, because that's what 81 is. So that's x plus 9, x minus 9 for that one. We'll do one final difference of squared one, because 16x squared is actually 4x all squared, and 1 of course is 1 squared, so what we've got there is 1 minus 4x like that. So our brackets will be 1 minus 4x, 1 plus 4x. And there's a wee range of different quadratics to factorise.